Now what I can do is individually set the use rates as well if one physical item may demand more of those costed resources than any other within a system. So say for support and test equipment, I can select it from an item. Say for the feathering pump, I can edit the rate, and I might say that this uses 25%. And what it does is it spreads the rest of the usage rate across the other items. You'll notice I've got two feathering pumps there, so I'll edit this one as well. And you'll see now that the usage rate has been reduced even more across all the other items there. So I'll just save that and close that window. And you'll notice now that the usage rate for S&TE is different, and you'll see it'll change here for other items. Okay. Now one thing, you'll notice that I haven't done any analysis on the brake unit prop. If I set that to Y, I'll get a warning saying that there's a lower assembly there that may be changed to the same status, and it can let me do it here. Now the reason this is a problem, well, there's two reasons. One is that this actually belongs to a different system, the hose. You can see there that it's red, and red items are not linked to this system. Now these items here belong to system X3202. This item here belongs to system X3204. So that's something that people need to be aware of when they're conducting analysis, that the analysis for this item will actually roll up to X3204, not X3202. And also this item here is currently under analysis, so we didn't want it to be set to Y. It would have reset the analysis for us. Okay, that's just one little aside there. Okay, so looking at the brake unit, what we can do is perform eLORA, and we've got this little sort of like a mini wizard, and for analysts that go through the normal process of doing a cost threshold, non-economic analysis, economic and determining decision, all you really need to do is hit next step every time to follow through that process. If you want to jump in, which we will later on, and have a look at other parts of the analysis that's not in the process flow, so we may want to jump directly to non-economic and skip cost screen, you can actually do that as well. The first thing that needs to be done though is just editing some items. So we need to set the item details before we start the analysis. So the mean time to repair, the cost, mechanical, electrical, and the weight, say 5 pounds. Now, because it's more than $10,000, when we begin the eLORA, we calculate it, it'll say, this is just straightforward, the item cost exceeds $2,000, so we need to do more in-depth analysis. Non-economic is mandatory, and then possibly economic based on the non-economic analysis. And of course, it takes you directly to the non-economic screen. Now I'll jump out of this one because conducting non-economic analysis is quite time consuming, and I've already got one that's almost done. This is typically based on Appendix Q from Mill Standard 1390D. So I'll just jump out of here. I'll go to the unit prop control. You'll see that my non-economic is incomplete. I'll just pop straight into that, and I have already conducted some analysis here. So these questions are actually user definable. You can go to tools and add a consideration, edit or delete. So you can have more than 20 questions if you want, less, and you can structure these the way you want them to. In this particular example, these have been structured for a particular project we've conducted recently, but you can structure these questions any way you like. Now, when resuming a non-economic analysis, we've built eLORA so that you must maintain an audit trail. Now you'll notice here that I can't just go to question 20 and put a rationale in there. It won't let me because it's read only. What I need to do is actually say I want to start a new eLORA, and it's telling me that I'm about to create a new reasoning settings. I can press yes to maintain the current reasoning and continue from there, or start from scratch. So I'll say yes because I want to finish this off. You'll notice now it has today's date on it. I don't know if you noticed before, but the previous one had a previous date. I'll put something in here to say continuing analysis, and if I now go to 20, I should be able to put in finish off my rationale. I'll say no. Now I'm not going to go into a lesson on eLORA. If you understand how the preempting factors and non-economic analysis works, I'm just putting in values there to allow me to put the appropriate echelon in. Now the way that eLORA works for this is it will pick the reasoning that that is at the lowest level of maintenance, and that's what it picks for the determination of the last three characters of the SM&R code for the non-economic portion of the analysis. So somewhere in here, there will be one or more ODDs. So the SM&R code at this point would be something like PA ODD. Because I put OOO there, that is overridden by an ODD. That's as simple as the economic, or sorry, the non-economic rationale is. I'll save that one, and I'll just say my non-economic is complete. Now, if you noticed down here, I'm doing this on the unit prop control LCN A01AA38. We also have another unit prop control because this aircraft has two propellers, A02AA38. Because these items share the same part number, in the general case, they typically can have the same SM&R code. That's not always the case, particularly for the use code, the third character of the code, because in some instances, depending on where that item is fitted to the piece of equipment, the use code can vary from O to D, because depending on how accessible the item is. But what eLORA does is it recognises that there are other items of the same part number. It saves you having to conduct the analysis on the other items as well. So you can say, yes, I want it applied to this one, and click OK. So we've saved that. You can see here that we now have an audit trail. I can go back to the previous analysis if I wanted to, and I'll close that. So you can see now that our non-economic analysis is done. Now, with regards to economic analysis, we'll have a look at that. Now I can either press next step, or I can just hit the economic analysis button. It's telling me that there's no current economic analysis for this item, and that my documentation, support and test equipment, test program set and training data has been initialized for the common values. So if we go and have a look there, you can see there's the values that we saw before. Now, one thing I didn't do before with this item was edit the item details like I did with the brake unit prop control. So I'll do that now. So I'll give it a mean time to repair of 2.5 hours, say a unit cost of $25,000, 400 hours a year, a weight of 5 pounds. I'll just put the same data source reasoning in. Repair turnaround time at OM, let's just say 10 days. Cost for shipping, say $15 a pound. For DM, let's say the repair turnaround time is 90 days, and the same, $15 a pound. Let's have a quick look through these items. Yep. There's a problem there. That should be a percentage, so I'll say 10%. And let's just say 20%. Oops. Okay. Now, typically, conducting an economic analysis would be a lengthy process. Most people who have conducted eLORA know that eLORA analysis is very data hungry. I'm just plucking figures out of the air here, but obviously these numbers would need to be substantiated somehow. So I'll just go over to the calculations tab. It's telling me that my numeric data has changed, so we need to recalculate. So I'll hit the calculate button, and you can see in this case that the recommendation is DD. So what that's telling me is that this item should be repaired, and it should be repaired at depot level, and the disposition should be conducted at depot level as well. You'll notice that it doesn't have the first character for use, because that's normally determined through your non-economic analysis. So how accessible is it? What level of maintenance has the tools, the training, the capability to remove and replace this item? So that's a determination that's made outside of the economic analysis. You can see here we've got a whole bunch of numbers that is calculated. I won't worry too much about those for now. What's more important is the sensitivity analysis. What I'm going to do is just jump out of this one. I'll save that, and I've got another one that I conducted earlier, which we'll look at for sensitivity analysis, and that's the feathering pump. So let's go have a look. So in this case, I can jump straight into the economic and just say yes. I can say yes because I won't save this. Now, one strong feature we believe of our application is conducting sensitivity analysis, and this is very, very good because you can also do some what-if analysis, because sometimes as you know, as analysts, we know that our numbers can be quite rubbery, and we may be told, say by the reliability engineer, that we have a range of MTBF of between 3,000 and 5,000 hours until the item has been had a parts count done on it, or it's been tested somehow, or it's even gone through a reliability program. So we can conduct some what-if analysis over a range of numbers and see how that affects our disposition. So we'll go have a look at the sensitivity analysis and see what we can do with this item.